All right, Iowa, we have a whole lot to talk about in tonight's video here, February 10th, just after 10 o'clock p.m. It's a little bit of a late video for this channel, but I wanted to get this out there and in front of you. This storm system coming Wednesday has escalated quite quickly. If you've watched our last couple videos over this weekend, models have been really up and down in terms of the total forecasted snowfall. And even today, about 24 hours out from the start of this system, there's quite the discrepancy between the models. And we're going to go a little deeper tonight. We're not only going to look at different models, but different products within the models and what that may mean for our snow totals. For right now, our watches, warning, and advisories put out by the National Weather Service include still a winter weather advisory here in northwest Iowa. That's for what's been happening already today. What we're concerned about with this video is what's going to come late Tuesday through your day and even into the night on Wednesday. The teal color here, that's a winter storm watch, and then the pink winter storm warning already in effect with confidence there in Missouri and northern Kansas. Looking at the simulated precipitation type, this is the GFS model, and you can see that low tracking here in the south and moving up the Ohio River Valley. That's what's bringing this snow here to the northern side of this storm system here in Iowa, and it does two things for us. That storm being that far south keeps the warm air farther south in the warm sector, and keeps our temperatures downright cold, influenced by the areas of high pressure here in the northern U.S. and Canada. It also does limit some moisture advection up here into our state, with the heaviest moisture advection staying far to our south and southeast. But those two, as we're going to discuss, kind of offset each other. First up, this is our expected snowfall totals. This is from the Euro model. And we're going to go over a few, so be patient, and I'll kind of explain. Des Moines, 4 inches, 3.7 down in Burlington. One consistent thing, generally through these models, northern Iowa is going to see the least amount of snow and generally get heavier the farther south you go. Some models are going to show heavier amounts to the west, some to the east, even some right smack dab here in the middle. Now, we're showing you a lot of maps here because these are the possibilities. These are eventualities, outcomes that could happen. This is actually the very same model, run at the very same time. Most of these models, by the way, were generated at noon today on Monday. And you can see quite the difference there. 5 inches. Oops, went too far. And so far on this channel, we've primarily looked at the standard 10-to-1 snow ratio. Very simplistic terms. If this were rain, if we got an inch of rain, it would equal about 10 inches of snow. So, why are we showing you something a little different? This is the Kuchera version. Same information, same time, from noon today, but vastly different results. So what this product does is it doesn't just kind of take a standard look at the temperature, but the temperature with height, up to 500 millibars. And in this time of year, if we think of all the convection, the actual storm, the clouds, that's going to go pretty much about halfway, maybe 2/3 of the way to the top of this mass, this storm. But it's looking at how cold that area, that column of air is above the surface. So to kind of better illustrate that, this is a modeled sounding from the GFS from Des Moines at noon on Wednesday. 18Z is noon during Central Standard Time. And there's a lot going on here. Just focus generally in this square. This is a skew T. And I'm going to point out something called dendrites. Basically, if you think of a snowflake, the little arms, the little crystals that shoot out from the center, that's the dendrites. And in certain environments, those snowflakes, they grow, they get bigger, or can be smaller, depending on the environment, the temperature, and that they're in. What is different about this storm that I mentioned earlier, because we are so far north, so far removed from the main storm, we're dealing with some pretty cold air. And all of you know that the cooler, drier air tends to make a lighter, finer, lightweight type of snow, versus when we're closer to the freezing mark, we get that real heavy, slushy snow. So however much snow does fall is going to be great for sledding, not so great for snowballs and snowmen. The property to also keep in mind that with the lighter, drier, airier snow is it accumulates higher. It doesn't compress as much, and there's more air in the snow. It takes up more space. So, assuming that those bigger snowflakes grow best in the -12 to -17 Celsius, which I've highlighted here in pink. And this chart's a little weird. It's skewed because the x-axis isn't kind of plotting straight up and down. It's at a 45-degree angle. So -12 degrees Celsius here is also -12 degrees Celsius here, -17, -17. So this area right in here is our growth zone for the snowflakes. This line, the actual plot, the air temperature and the dew point temperature, is predominantly located in that growth zone. So we're looking at, more than likely, some pretty good sized snowflakes. It's not until we get up here near the top, and this blue line represents 500 millibars. So that Kuchera model that we were just looking at is concerned with the temperature profile from the surface all the way to that 500 millibar mark. Sorry for the science lesson. Hopefully you're following along here. Main takeaway is this thermal profile is largely located within that growth zone. So we'll move on from there. With that said, let's look at a couple other models, both the standard 10:1 ratio and the Kuchera model. So this is our GFS. You can see 3 inches in Des Moines, 3.5 in Iowa City, heaviest amounts down there in southeast Iowa. Same picture, same model, GFS, but again, the Kuchera model, and showing a lot more snow falling and accumulating in those areas. 6 inches in Des Moines, 6.5 Burlington, Waterloo, 4.5. You guys can see the whole map. So let's take a look at a shorter range but higher resolution model. This is the NAM 3K, and very similar to the Euro that we looked at, but the heavier amounts, not so much here in southeast Iowa, but southwest Iowa. That's different. And if we look at the Kuchera model, well, it's way different. Pretty large amount of snow falling there in western Iowa and Nebraska. And you'll notice this isn't where the current winter storm watch is. So more than likely the National Weather Service is not looking at our NAM 3K model. But again, just wanting to show possibilities and eventualities. Earlier in January, when we had our last, big threat of snow, we looked at this model, and this is the SREF or SREF, and it is a averaging of 22 different models. And the idea is, if you look at a bunch of models and you average them out, maybe that's going to be the most accurate picture. And back then, kind of like it is today actually, it was showing 4 inches in Des Moines and 8 to 10 inches down there in the southern part of the state and into Missouri. And what actually happened is Des Moines got nothing, and about 2 inches fell down there around Lamoni. And it's because that particular storm, the gradient was very sharp between no snow and a lot of snow, and it overall just tracked farther south and left most of the state without any snow. So, but I still believe, even though back then you got it wrong, there's still some value in averaging out the different models and seeing what could fall. But I want to point out to you again, this is the standard 10-to-1 ratio in Kuchera. Unfortunately, there isn't a Kuchera SREF version to show you. So, what's our conclusion to this point? 24 hours out to the beginning of this system, it's still very much up into the air. You can start to see why your local TV weathermen have such a hard time predicting with accuracy how much snow will actually fall where you live. And it's because there's a lot of conflicting information. If these were all saying the same thing, then we would speak with a whole lot more confidence. But winter weather, and particularly predicting snowfall totals, it is very complicated. It's not just looking at what the temperature is at the surface, but going back here and realizing you also have to account what's happening much higher up in our troposphere, the lowest level of the atmosphere. What's the National Weather Service have to say? As just about an hour ago, they updated this map, and these are their current forecasted totals, and you can see there's a pretty wide gap, and rightfully so, as we've been looking at these different models. They're calling for 5 to 9 inches here in Des Moines, 6 to 10 maybe an area in southeast Iowa getting a foot of snow. It's definitely in the cards, but it does seem to be across all the models in pretty good agreement. Not a tremendous amount of snow for the northern tier of the state, but really the entire state, we're looking at some snow for your Wednesday. It's going to cause travel impacts for certain. We've had a very dry, mild winter so far, so we just aren't really used to dealing with. In fact, the last time we had this much snow was 13 months ago, January 2024, when we had our blizzard across the state. So it is something to be prepared for, no matter where you live in the state. Even Spencer, 4 inches of snow is enough to cause a little bit of a headache. Obviously, a much bigger headache when you get closer to that 8 to 12-inch range. So we're just going to have to see as this develops. I'll likely have another video out here tomorrow, Tuesday afternoon into the evening hours. And we're just going to prepare you for what might happen. I appreciate you sticking along this far into the video. Hopefully you learned something, found something of value. If you did, consider hitting that subscribe button. Consider telling a friend, and we'll see you on the next video. Have a good night.